A single loose wire, 6 seconds of collapse, 6 workers dead, and a price tag that has now climbed past $5 billion. On March 26, 2024, at 1:28 in the morning, the container ship MV Dali slammed into Pier 17 of the Francis Scott Key Bridge in Baltimore, Maryland, and the entire structure fell into the Patapsco River before anyone could react. What came next was the largest marine salvage operation in American history, an 11-week sprint to reopen the shipping channel, and the start of a reconstruction project that has more than doubled from its original $1.9 billion estimate. The replacement bridge now rising from the water will look nothing like its predecessor, because it's being designed to survive impacts from ships that didn't exist when engineers first drew up plans back in the 1970s. Understanding why the Key Bridge failed so completely starts with understanding what struck it. The MV Dali is a Neo-Panamax container vessel built by Hyundai Heavy Industries in 2015, stretching 984 feet long, which is nearly 3 football fields, with a beam of 158 feet and a container capacity just under 10,000 TEU. That March morning, her holds contained 4,680 containers, weighing a combined 56,675 metric tons, and 56 of those containers carried hazardous materials. Fully loaded, the ship weighed approximately 213 million pounds, or about 100,000 tons. Grace Ocean Private Limited of Singapore owned the vessel, Synergy Marine operated her, and Maersk had chartered her for the voyage from Baltimore to Sri Lanka when everything went wrong. After 22 months of investigation, the National Transportation Safety Board pieced together exactly what happened. At 1:25 in the morning, just 3 minutes before impact, a low-voltage breaker tripped aboard the Dali and plunged the entire ship into darkness. The crew scrambled to restore power, but multiple problems hit them at once, including high-voltage breakers set to manual mode, which stretched the blackout from what should have been 10 seconds to 58 seconds. Even when power came back, the fuel pumping systems couldn't restart properly. Propulsion and steering went dead less than a minute before the ship reached the bridge. The crew acted quickly, according to the NTSB, but nothing they did could change what was already inevitable. And the cause of that initial breaker trip turned out to be almost absurdly small. An improperly installed wire label banding had prevented a signal wire from seating fully into its terminal block, and that inadequate electrical connection brought down a bridge that had stood for nearly half a century. NTSB Chair Jennifer Homendy delivered her assessment at the November 2025 hearing with no softening of language. "None of us should be here today," she stated. "This tragedy should have never occurred. Lives should have never been lost. And as with all accidents we investigate, this was preventable." The Francis Scott Key Bridge opened to traffic in 1977 as a continuous steel truss, what engineers classify as fracture critical. That technical term carries a simple and devastating meaning. The structure contained zero redundancy, and removing one critical support meant losing everything. Approximately 31,000 vehicles cross the bridge every day on Interstate 695, the Baltimore Beltway, and trucks carrying hazardous materials used it as their primary route since the harbor tunnels prohibited such cargo. The bridge also served as the main access to the Port of Baltimore, which handles roughly $80 billion in cargo annually and has held the #1 national ranking for automobile imports for 13 straight years. The moment the Dali struck Pier 17, the bridge's truss structure pivoted like a seesaw around the surviving pier, and excessive tension forces triggered sequential failures across all 3 main spans. Total collapse came in approximately 6 seconds. But here's what the NTSB investigation uncovered that should alarm everyone who crosses a bridge near a shipping channel. The Key Bridge's vulnerability to ship strikes exceeded the acceptable risk threshold established by engineering standards by nearly 30 times. Those 4 rubber-fendered concrete structures called dolphins that were supposed to protect the piers measured just 28 feet in diameter, and in the NTSB's own words, they proved woefully inadequate for modern vessels. The Dali passed right between them and hit the pier directly. Back in the 1970s, when the Key Bridge was designed, the largest container ships might carry 3,000 TEU. The Dali carries nearly 10,000, which means ships have grown 3 times larger, while the bridge's protection never changed to match. Had Maryland's Transportation Authority run the vulnerability calculations using current AASHTO standards, they would have known the risk was unacceptable. A crew of 8 workers from Bronner Builders was on the bridge that night, filling potholes during a routine maintenance shift. All of them were Latino immigrants. 6 of them died when the bridge fell. 2 workers survived. A state highway inspector escaped without injury, and Julio Cervantes Suarez got out of his sinking truck by rolling down a manual window. His lawyer later pointed out that he survived specifically because his window wasn't electric. The escape crushed his chest. But he lived. The NTSB investigation exposed a devastating gap in the emergency response. Maryland Transportation Authority police started closing bridge traffic after receiving the Mayday call from the Dali, but they never notified the construction crew directly. According to the NTSB, had workers received the same alert that police did, they may have had approximately 90 seconds to evacuate safely. 90 seconds stood between 6 families getting their loved ones back and the tragedy that unfolded instead. Beyond the deaths and the destroyed bridge, the collapse completely blocked the shipping channel to the port of Baltimore, which was costing an estimated $15 million per day in lost commerce. Initial expert predictions said reopening could take 11 months, but the actual time came in at just 76 days. A 6-agency unified command coordinated the salvage effort, including the Coast Guard, Army Corps of Engineers, and Navy salvage specialists. At peak operations, 22 floating cranes, 10 tugboats, 9 barges, and over 1,500 workers crowded the site. The star of the operation was a crane called Chesapeake 1000, nicknamed Chessie. She's 52 years old and the largest crane on the East Coast with a 1,000-ton lifting capacity, and her history includes a classified mission you might not expect, because she was previously used in Project Azorian, the CIA's Cold War operation to raise a sunken Soviet submarine. Now she was pulling twisted bridge steel from the Patapsco River. Every aspect of the work posed challenges. Bridge sections had twisted in ways engineers didn't predict, storing dangerous tension that could cause pieces to snap back when cut. Parts of the structure had driven into the riverbed mud like a knife at depths reaching 50 feet. Salvage divers worked in visibility of just 1 to 2 feet, relying on surface operators using real-time 3D sonar imaging to guide them. Lightning storms, water temperatures around 48 degrees Fahrenheit, and swift currents created additional delays throughout the operation. The final debris total reached approximately 50,000 tons, broken down into 16,000 tons of steel, 10,000 tons of concrete, and displaced sediment, with the largest single lift weighing 630 tons. On May 13, 2024, crews used precision explosives to perform a controlled demolition that removed more than 4,000 tons of bridge from the Dali's bow. 1 week later, on May 20th, the ship was finally refloated and towed away after spending 55 days trapped under the wreckage. The shipping channel reopened fully on June 10, 2024. Salvage costs reached approximately $100 million, with $75 million coming from the Army Corps of Engineers and $24 million from the Coast Guard, all covered by federal emergency funds. Governor Wes Moore summed up the achievement. While many said it would take 11 months to reopen the Port of Baltimore, this team got it done in 11 weeks. The replacement now under construction represents a complete departure from what collapsed. Maryland's first cable-stayed highway crossing will feature twin towers exceeding 600 feet in height, and the cable-stayed design provides something the original truss bridge completely lacked, which is redundancy. Multiple cables distribute the load, so losing one cable doesn't trigger catastrophic failure. Comparing the specifications tells the story of how dramatically bridge engineering and ship design have evolved over 50 years. The original main span measured 1,200 feet, while the new span will stretch to 1,665 feet. Original height above water stood at 185 feet, and the new bridge will rise to 230 feet, a full 45 feet taller. Original towers reach 358 feet, but new towers will exceed 600 feet. The shipping channel beneath the original bridge measured 700 feet wide, and the new channel will span approximately 1,000 feet. And then there's pier protection, which may be the most critical change of all. The original bridge relied on those 28-foot diameter concrete dolphins that failed completely against the Dali. MDTA Executive Director Bruce Gartner describes the new pier protection systems as larger than a football field. Those massive protective structures account for a major portion of the cost increases, but they're not optional anymore. They represent exactly what was missing in 1977. Officials first estimated the rebuild cost in April 2024 at $1.7 to $1.9 billion. By November 2025, that figure had climbed to $4.3 to $5.2 billion, more than doubling in just 19 months. Acting Transportation Secretary Samantha Biddle explained what drove the increase, noting that material costs for all aspects of the project have risen drastically, and that the updated cost range and schedule directly correlate to increased material costs and to a robust pier protection system designed to protect the new Key Bridge. Federal Highway Administration data shows highway construction costs have jumped 72% over 5 years. Stack on top of that the football field-sized pier protection systems, the taller towers required for the longer main span, and federal design mandates for current safety compliance, and the price tag starts making sense, even if it stings. The original completion target of fall 2028 has now slipped to late 2030, adding approximately 2 years to the timeline. One piece of good news arrived on December 21, 2024, when President Biden signed the American Relief Act, authorizing 100% federal cost coverage for the entire rebuild. Maryland Senators Van Hollen and Cardin noted that federal taxpayers will be reimbursed through insurance payments and litigation proceeds. On the legal front, Chubb Insurance paid out $350 million, their policy limit, to Maryland in August 2024. Grace Ocean and Synergy Marine, the ship's owner and operator, settled the federal cleanup lawsuit for $102 million. Maryland has filed its own lawsuit seeking full reconstruction costs plus punitive damages, with trial expected sometime in 2025 or 2026. Lloyd's of London estimates that total claims from this disaster could approach $4 billion, which would make it the largest maritime insurance loss in history. Work as of late 2025 is moving forward on multiple fronts. Crews are driving massive test piles into the Patapsco Riverbed, 12 of them in total, each measuring 8 feet in diameter, over 200 feet long, and weighing approximately 340,000 pounds. Testing subjects these piles to 10 million pounds of force to validate the foundation design, and 6 had been installed by November 2025, with the program expected to finish by early January 2026. The geology poses serious challenges. The first 60 to 70 feet of riverbed consists of very loose sediment, which means piles must penetrate through this soft layer to reach the hard rock beneath. Engineers shifted the new bridge alignment approximately 260 feet southeast to avoid both debris and zones of loose soil discovered during surveys. Demolition of remaining original bridge structures, including ramps, piers, and approach spans, started in July 2025. Crews have removed approximately 10,000 tons of concrete decking and stockpiled it for recycling. Design work has reached 70% completion in just 14 months, and MDTA points out that comparable projects typically take 7 years to hit this milestone. Nebraska-based Kiewit Infrastructure won the construction contract in August 2024, initially receiving $73 million for Phase 1 pre-construction and design work. A WSP-led engineering partnership called Bridging Maryland secured a $75 million consultant contract to oversee the project. The NTSB's final report went beyond identifying the loose wire that caused the blackout. The board recommended evaluating 68 bridges across the United States for risk of collapse from vessel strikes, because the Key Bridge wasn't unique. It was simply the one that failed first. NTSB Chair Homendy framed the broader reality clearly, stating that there's hardly a structure in the country that could have survived that kind of impact. The goal of the new bridge is to become one that can. Every feature of the new design, from the cable-stayed structure to the 600-foot towers, to the football field-sized pier protection, to the wider channel and taller clearance, exists because ships kept growing larger, while bridge protection remained frozen in the past. The Sunshine Skyway Bridge in Tampa Bay collapsed in 1980 after a ship strike that killed 35 people. And that replacement took 7 years while introducing cable-stayed design with improved pier protection. The Key Bridge follows that precedent with even stronger safety features. The I-35W bridge in Minneapolis collapsed in 2007, killing 13 people, and that replacement was finished in just 13 months. But that bridge measured only 1,907 feet long, about 22% of the Key Bridge's length, and it didn't cross an active shipping channel. The comparison reveals just how much more complex the Baltimore project really is. Late 2030 should see drivers crossing a structure that bears no resemblance to what fell. Twin towers will climb over 600 feet into the sky, with cables radiating down to support a deck 230 feet above the water. Ships passing below will have nearly 300 additional feet of channel width to navigate, shielded by barriers spanning areas larger than football fields. The final cost will exceed $5 billion. The delay will add 2 years beyond original projections. 6 families will never see their loved ones again. But the structure rising from the Patapsco will be engineered for the ships of today and tomorrow, not the ships of 1977. Redundancy that the original lacked, protection that might have prevented this disaster, and a 100-year design life that anticipates challenges we haven't yet imagined will all be built into every element. Governor Moore acknowledged the hard truth at the center of the story when he unveiled the new bridge design in February 2025. The original Key Bridge couldn't have survived what hit it, and almost no bridge in America could have. The task now is building one that can, and making sure the 67 other vulnerable bridges identified by the NTSB receive the same scrutiny before another loose wire, another blackout, and another ship claims more lives. That's the legacy of the 6 workers who died filling potholes on a March night in Baltimore. They deserved 90 seconds of warning, and what they got instead was a bridge that couldn't protect them, and a system that failed to alert them. The new bridge being constructed in their memory is designed to ensure that never happens again. If you found this breakdown helpful, consider subscribing and hitting the notification bell so you don't miss our next deep dive into engineering and infrastructure stories that shape our world.